All right, guys, so for today, notes probably won't take too long today, and then we'll have time to do like 2 different activities to go with all this. So we looked at how to simplify a single radical on Friday, right? Making your factor tree, looking for the pairs outside, singles inside. So today we're going to look at how to multiply them, and then we're going to also look at imaginary numbers today and kind of put them all together. So when we're multiplying with radicals, as long as they're both under a radical 5 times radical 3, they're considered kind of like terms that you can put together. So then you can change it to radical 5 times 3. We can actually multiply them to make that radical 15. Okay, so radicals can multiply together. They stay under the radical. So here we did radical 2 times radical 6. Multiply them together gives you, the problem did this very weird to me. That would be radical 12. And then you could split that apart, right? We could do our factor tree on 12. 2 and 6, 2 and 3. You'd look for your pair of 2's, which would come outside as a single 2. Single 3 stays inside underneath the radical. Okay, so very similar to what we did on Friday, except we have 2 of them to start. We can multiply them together and then go ahead and do our factor tree. Okay? So number 1, radical 6 times radical 15. What's 6 times 15? That is 90. So that would become radical 90. And now it's just like what we did on Friday. So we'll do our factor tree. So what do you multiply to get 90? 9 and 10. Okay, 9, 30 and 3. Good. And those are prime, so I'll go ahead and circle those. And then 10, 5 and 2. And those are both prime. Good. We're looking for pairs. We got a pair of 3's, so it comes out as 3. Singles stay inside. 5 and 2 make 10. So, earth-shattering, harder than last time, right? 1 extra step's not too bad. All right, so number 2, notice we have a number already out front. It's all right. He's already outside. We're going to leave him outside. But what's radical 10 times radical 32? Good. So the 2 stays out. And that's going to become radical 320. And then we can go ahead and break this down just like we did before. What do you multiply to get 320? What? 32. It's kind of obvious, right? Like you just started there. So 32 and 10. 10. 5 and 2. 32. 8 and 4. Interesting. It's probably not where I would have went. That's all right. 4. 8, 4. Whew, lots of 2's. All right, so let's keep track of what we got going on. Looking for pairs. We have a pair of 2's. Single 2 comes out. What else you got? Another pair of 2's. Single comes out. Another pair of 2's. Single 2 comes out. Singles. We got just a 5 left over. Am I forgetting anything? Good. The 2 from the beginning, make sure that one comes down. Lose track of them because you got a lot of 2's going on there. Very good. 16 and radical 5. Number 3. What do you want to do first? There's a negative. Does it matter? No, it doesn't matter. So notice you have numbers outside and you have some numbers under radicals. The numbers outside, we can multiply those together. So what's negative 2 times 5? Good. All right, so we're just multiplying those together. And then your radical numbers, we can multiply those. 108, thank you. It's too early on a Monday morning to do that in my head. Now what? Good. We're going to go factor tree, right? You said 12 times 9? 12? 4 and 3 or 6 and 2, doesn't matter. And then 4, 2 and 2. 9, 3 and 3. What do we got a pair of? Pair of 2's. Pair of 3's. Singles. 3. Don't forget that negative 10. So negative 10 times 2 times 3. negative 60 radical 3. Questions so far? Good. All right, guys, so on number 4, what was the first thing you did? Good. Multiply the outside, multiply the inside. So 9 times 6? 14 times 21? 294. All right, and then I'm hoping your next step was to break down that radical. 6 times what? 6 times 49? I would have probably went 14 and 21. That's where I started. Doesn't matter. All right, so then 6, 49. All right, so pairs, pair of 7s. And we have single 2 and 3. Don't forget that 54. Ooh, our numbers got big out here. 378, radical 6. Good. All right, number 5. People panic because there's a fraction there. Because it's ugly. A lot of students are like, oh, fraction, I'm not doing it. I'm like, people, it's a fraction, it's a number. Half is a number. People panic over that all the time. It's just a number. So we're going to go ahead and start with, we can multiply the radicals, right? Half still stays there. What is 72 times 12? 864. Now we're excited, right? That's going to be a good factor tree. What do you multiply to get 864? Good, you guys are learning. All right, 72 and 12. 72? I can see you guys really thinking about that. 12 and 6. I probably would have went 9 and 8. Yeah, that's where I would have went. It doesn't matter. You can go either way. All right, so 12. 4 and 3. 4. 2, 2. 6. 2 and 3. Another 12. For giggles, we'll go 2 and 6 this time. And then 2 and 3. So imagine if you forgot to circle all your primes. How confusing that might look. Very confusing. So make sure you're circling primes. Kind of help yourself out. So let's look for pairs. Pair of 2s. Another pair of 2s. Pair of 3s. And I have a single 2 and a single 3. And let's not forget the half out in front. Yeah, it's just 6 radical 6. That's not ugly. What's half of 2? 1. Times 2 is 2. Times 3 is 6. That's not ugly. Now, we'll deal with stuff in this class that gets real ugly, but that one's not so bad. Hey, look at the fraction. It's scary, right? She does not like fractions. All right, so same idea though, right? What should we do first? Multiply, good. So we have 2/5 times, what did you say, 450? Good, so I multiplied it all together, and now let's factor tree it. What do you, 30 and 15? I probably would have went 45 and 10. Don't you guys ever see that, like, 0 on the end? You're like, I can divide that by 10. Ends in 5, like, I can divide by 5. That should hopefully come second nature to you. All right, what about 30? 6 and 5. 3 and 2. 15. 3 and 5. All right, so what do we have pairs of? Pair of 3s. Good, pair of 5s. And we have a single 2. And don't forget my fraction. Can I help you guys real quick for a minute with fractions? Real quick. Well, let me try to help you out a little bit, because people panic over these. Guys, what does the fraction bar mean? It means divide, right? So what's 3 times 5? What's 15 divided by 5? 3. Times the 2 makes 6. But did you see how I did that in my head? I know you guys panic over fractions. I did 3 times 5, which is 15, divided by 5, which is 3, and then you multiply by the 2, which gave me 6. You don't need calculators all the time, guys. Fractions are not that frightening. Yeah, they're not real fraction. You can do them, but it's not as easy. All right. So that's multiplying radicals. And now we're going to I'm going to introduce imaginary numbers. Imaginary numbers, I'm going to guess you guys have never seen. Anybody seen imaginaries? The eyes? A couple of you? Oh, if you've retaken the class, you've hopefully seen them before. Or if you took some higher level courses before. But guys, imaginary numbers is an Algebra 2 concept. This is not something you typically see in Algebra 1. Okay? Did you guys read the little cartoon? It's funny. I think it's funny. I think it's funny. All right, but guys, I'm going to show you just a real quick couple-minute video. All right, so imaginary unit I is the square root of -1. So in other words, I equals radical -1. All right, because up till now, if I had asked you what's the square root of, like, let's say, -4, could you have told me? Because some people are like, oh, it's 2. And other people will say it's -2. But what's 2 times 2? +4. Not going to work. -2 times -2 is +4. So it's going to get you positive both times. So that's why neither one of these actually work. So we needed some other way to kind of handle this. Otherwise, anytime you're doing different calculations, you'd end up at a point where you couldn't do anything. So that's where they kind of discovered the imaginary numbers. So what would I squared be equal to? Well, let's take a look. If I equals the square root of -1, and I want to know I squared, that means I'm squaring both sides of my equation, right? To make it I squared. What's the square root of -1 squared? You guys are funny. What happens when you square a radical? Yeah. They kind of cancel each other out. So I squared is actually equal to just -1. And this is going to come up later this week that we'll need to make sure we know that. I squared is equal to -1. If you go on into pre-calc or calculus, you get into a lot of looking at like I cubed and I to the 4th and things like that. All right, but for today, we need to make sure we know I is the square root of -1. Okay. All right, so let's kind of practice, see how it works. To be honest with you, simplifying things with an I in it is actually really easy. Okay. So if I have radical -12, as of right now, or before today, you'd have been like, I don't know, I can't really do that because there's a negative under there. But now we can. If I can pull apart like that. We just talked about multiplying, where I can multiply them together to get the single radical, right? -1 times 12 would give me -12. So I didn't change the value, right? I just pulled apart this -1 out in front. What's the square root of -1? Square root of -1 is, it's I. It's I. That's where your I comes from. So now this is I. I can kind of pull that out, call that an I, and then I can break this down. That'd be 4 and 3, 2 and 2. So I have a pair of 2's, which would come out with my I, who's already out there. And I'd have a single 3. So it's 2I radical 3. People always ask, can I write I2? Technically, yes. Would you write x2 or would you write 2x? You'd write 2x. I kind of acts like a variable. Like the same way you would treat an x, that's kind of how we treat an I. Same idea. So in other words, if I'm looking at this, if I have a negative under my radical, you're going to have an I in your answer. Okay? So if you have a negative under your radical, your answer has an I. So honestly, what we've already learned about how to simplify with radicals or multiplying radicals and whatnot, I'm okay. I do the same thing, but if I see a negative, pull it out, make it an I. Easy as that. So number 2, there's a negative under my radical. What do I know is part of my answer? I. So right away, I could switch this and make this I radical 45. Pull that negative out as the I, and now it's just like what we've been doing. So how would you break down 45? 9 and 5, 3 and 3. So we have a pair of 3's and an I. Good, and radical 5. Negative under the radical makes an I out in front. So what about number 3? What's that answer? 7I. Yeah, because this negative is going to give me the I, and the square root of 49 is just 7. So it's 7I. Okay, so number 4. What are you going to do first? Yeah, recognize right away there's a negative under here. That's I radical 108. And then let's break down the 108. 12 and 9. Okay, then 12. 4. 2 and 2. 9. 3 and 3. All right, so we have a pair of 2's. Got a pair of 3's. I have a single 3. And don't forget I have the I. So that gives us 6I radical 3. So can you multiply a number with I times a number without I? Yeah, technically it looks like I just did that, doesn't it? Right? I can multiply numbers if one's an I and one's not. That's fine. I can multiply them together. So number 5, what would you do first? Take the negative out as an I. So I'm going to have 2I radical 300. Pull that negative out as your I. And now we can simplify from there. So 300, 30, and 10. Okay, 30. 6 and 5. It's always interesting to hear where you guys multiply with those. Then 6 is 3 and 2. 10, 5 and 2. Okay, we have a pair of 5's. Got a pair of 2's. Have a single 3. And then don't forget to bring down your 2I. So what do we get as a final answer? Good, 20I radical 3. So how much harder is this once we introduced I? Not, yeah, it's not. Go ahead and try number 6 on your own. All right, so number 6, what'd you do first? Good, take that negative out. So 5I radical 112. Say it again. 20. Oh, I'm like, okay, sorry. My brain was not processing what he just said. Sorry, Ramon. All right, 28 and 4. All right, and then 28. 7 and 4. 4. Another 4. 2 and 2. All right, so what do we got? Pairs of 2. Another pair of 2's. Single 7. Bring down the 5I, so we have 20I radical 7. You guys look good walking around. Any questions? All right, last 3 examples for today. Number 7. That one looks rough, doesn't it? What would you do first? I'm simplifying my radical. Just focus on the radical. Take out the negative. So we'd have negative 2 plus I radical 20. Right, just pull that out first. Notice I kept it right next to the radical, like I didn't move it in front of a plus sign or anything, because it's still part of the radical, so it's still touching that. Right, and then I can simplify the 20, right? 5 and 4. 2 and 2. So what do we get? We got a pair of 2's. We have the I and a single 5. What about that? Bring it down. All right, just kind of drop that down. Can I add that together? Are those like terms? Negative 2 plus 2i radical 5 is one piece. Is that a like term with a negative 2? No, that'd be as far as I can go. Later this week, we will talk more about how to add things like this together and when you can simplify and when you can't. That's a little glimpse into later on this week. All right, what about number 8? What did you do first? Good. We're going to pull that I out, so I radical 50. 10 and 5. 5 and 2. We have a pair of 5's. I have an I and a radical 2. Number 9. How many of you think number 9 has an I in it? I heard a yes. See lone wolf here? The only one who thinks there's an I in it? Is there a negative under the radical? The negative's not under there, right? The negative is under the radical. That's when we pull it out as the I. But this radical or this negative is it's already outside. It's kind of like negative 1 radical 8 sitting there. The number out in front is negative. So this one's not an I. I want to make sure we're recognizing the difference. Negative under comes out as an I. Negative outside, I don't care. You can stay outside. I don't want them. All right, so we'll break down the 8. 4 and 2. 2 and 2. Pair of 2's times the negative 1 that's already out there. Single 2. So negative 2 radical 2. All right, so I just want to make sure we're recognizing. Sometimes if there's a negative under there, we'll pull that out as an I. If there's not a negative under the radical, then there's no I.